Right. I'd like to introduce the next speakers. So we have Rob and Dmitry from Qualcomm giving us a status report in DRAM MSM. Welcome.
Thank you. Yeah. So maybe I should do the EO. That's the perfect one. So the DRAM MSM, Qualcomm display and GPU and everything. We have 36 platforms supported, starting from the very old and rusty hardware and up to SM8750, which was announced last year. We support 6 major generations of the GPUs. And that's as usual. We have 3 different core display drivers. We support DSI, DisplayPort, and HDMI. We have write-back support. And we will talk about some of new features. Is it? Yeah. So on the core side, yeah, as I said, there is a core. It's really only the blending and display processing, and we finally got the sorted out the UBWC, the Qualcomm compression or the Qualcomm bandwidth compression. We get a nice unified database, which hopefully can be shared with the video encoder and decoder driver, which can be shared with the camera driver. But for now, we are the only users of it, and at least all the compression capabilities of the hardware. We got the cleaner separation between the display and the GPU code. So we are slowly working towards getting all the bits and pieces less monolithic to get, now it's possible to disable all the KMS code and compile just the GPU finally. And we also have a kernel argument to make it possible to bind separately GPU and display. That might sound funny unless you have really looked into the driver, because previously on all the platforms, we collected all the different components, including display, including GPU, and bound them together, which made some of the developers unhappy. And another major change, Rob will talk more about it, and he talked on the first day. Now we require MMU for all the devices. So yeah, sorry for the developers hacking an 8964 and a few other platforms. You can no longer live without the MMU driver, and there is no MMU driver for those platforms. We got support for the few platforms since the last LTS. So that's the one of the IoT platforms, that's the augmented reality platform, and just a few mobile and IoT stuff. And finally, our driver always uses the DRAM bridge connector. So no, that's fine. That's also including the very obscure cases, but yeah, we are now all debank, whatever that means, clear. We don't have any connector implementation inside our driver. That was a long path, but we reached it. Oh. Yeah, so on the display core, on the display drivers, that's the oldest one, the first one, and we sorted out after several years, after several tens of years, how to drive the LVDS panel. That was a nice path. Yes, if you for any reason have an old Qualcomm device with LVDS panel, that might work now better for you. For the MDP5, that's the medium generation driver. No changes. That's the more in the maintenance mode. And on the GPU driver, that's the newest and the current generation's driver. We got some new platforms. We continue and we migrated. We added support for migration more over the platforms from the MDP5. And after the XDC, I actually plan to start purging driver platforms from MDP5 and 5 in favor of the DPU driver. We've got the thing which is common on the normal desktops, but not so common in the embedded side. We got the cloned mode, where it is possible to direct the output to one of the actual display outputs, and the write back. So it is possible to capture exactly what is being sent to the display, and use that for recording, use that for a wireless display, or for any other use case. Currently, it is supported only for the newest platforms since 8650, so just two devices. But I will talk more about that later. And finally, we merged another thing which took 3 years, if I'm not mistaken, to merge. We merged support for the virtual planes. The normal the block which supports blending of the frame buffer can only take up to 2.5K resolution. So for the bigger resolutions, you need to use two blocks. And that's not as usual. That's not supported by the core by default. We had to improvise. We had to create virtual planes which either take 1 or 2 blocks. And that's finally merged. Not yet enabled by default, but again, hopefully after the LTS kernel, we will toggle the switch. Then else, no. DisplayPort, yeah, our beast driver, or our hateful driver, as I said to some of my colleagues. We are finally preparing to get DP-MST support, so multi-stream. We got fixed, or almost fixed, all the use cases with link training tunable file repeaters, whatever that means. Yeah, that's the devices which usually sit in the docks. What? LTTPRs, yes. I'm happy that I finally got to remember what does it mean, because beforehand it was just yeah, so these are repeaters which are usually found in the docks or in the laptops. We sorted them out thanks to the colleagues from Linaro. And hopefully most of the docking devices should now work with the Snapdragon laptops. We sorted out the DP audio implementation using the audio helpers, which we added a few months ago to the DRAM framework. And the DP code now no longer has to register the codec, no longer has to care about all the details. Everything is handled by the DRAM core. And sad news, a few years ago we got panel self-refresh support. It had some issues, it was not enabled by default, and you can guess what happens with the things that are not enabled by default for some time. Yes, it has been rotten, it has broken, so once I tried to enable it a few months ago, and it did no longer work. So that's a quest for me or for one of my colleagues to fix. On the DSI side, nothing really significant. Thanks to another colleague from Linaro, he was adding support for the latest platform, and he just by passing by fixed several issues in the DSI-FI code. Thank you. On HDMI side, we migrated to the HDMI connector, which was done by Maxim. And we now use HDMI connector and HDMI audio helpers inside HDMI core. So also, more work on the framework, less work on the driver.
All right. Can you hear me? All right. On the GPU side, in the last year or so, we've added let's see, 5, 6, 7 new devices, filling in some of the older support for older devices. We already had several Adreno 700 devices supported, as well as the 2 new laptop GPUs. And also filling out some of the performance-related features, speed bin support for a number of devices, GMU bandwidth voting for a few GPUs, which let the GMU firmware more tightly control the bandwidth requests for the GPU. For the X Elite laptops, we got ACD, which is an adaptive clock distribution, which allows us to hit the higher operating points where sometimes the firmware needs to slightly reduce the clocks to prevent voltage droop momentarily. And speed bin support as well. And also, finally, IFPC, so-called interframe power collapse support for a couple devices. So IFPC lets the firmware move the GPU into power collapse and out on a much finer granularity than the CPU can. As far as new UAPI, couple years ago, there was some new UEPI added motivated by Vert GPU, but these days it's mostly driven by Vulkan. So we added a parameter to find out if ray tracing is supported, a couple parameters to query UBWC tiling modes for Vulkan host image copy. The ucache trap base, which actually is both a Vulkan and a GL shader extension. GL mainly came for free because it's all implemented in the compiler. We've exposed sync object timeline, and of course the big thing was what I talked about on Monday, VM bind. That was, a year or so in the making. As far as MISC cleanup, core, etc. changes, we split the device table in the kernel was starting to get unwieldy, so we split it into per generation hardware catalog, similar to what the DPU had done previously, so that we have separate files for each generation for the tables of GPUs in that generation. Added memory traces that Perfetto can use, for example, to monitor GPU memory used per process and globally. Another big thing was preemption support for Adreno 700. Kind of a little housekeeping thing, but to make life easier for people debugging when their DRM octals go bad, we added a way to log error messages for the user spacing driver specific octals. We extended GPU dev core dump with fault information, including like page table base address and page table walk and a few other debug registers to make it easier for debugging faults. Because of the increasing list of firmwares for all the different supported GPUs and the fact that we can actually probe the device without the firmware and just defer loading the firmware until each time user space opens the DRM device file, we just torpedoed all the module firmwares for GPU firmware so we don't have to pack all of those in the NIDRD. Like Dmitry had mentioned, we've switched over to the central UBWC config data. This helps. So many different blocks in the Qualcomm SoC support UBWC. They all need to agree on the same parameters and layout so that UBWC from the video decoder is compatible with the display or GPU or so forth. Previously, this was spread out in 2 places in DRM, plus in V4L2 and Cameron.
Plus 2 places in the, okay, that's all. Plus 2 places in V4L2, yes.
Yeah. So
and now we got just one for the oh, okay. So now we have just one place for the graphics, and still 2 places inside V4L. So that's still a room for improvement.
Right, and we can also actually properly deal with the fact that some of the UBWC settings should be different depending on memory technology, for example. And I'm back.
Yeah. So now the most interesting part. What can you expect from us? The pipeline. Yeah. As I said, we plan to turn on several of disabled features, or currently disabled features, but that's fine. We in the close pipeline. So for the next few releases, we will push the HDMI PHY drivers to a proper place, to drivers PHY. So from our responsibility to vNode, and we plan to continue separating parts of the KMS and GPU inside the single kernel object. So to make it easier to change the code, to make it easier to understand the code, and to make it easier to follow how different paths work inside the driver. For the display, for the DPU display unit, we are going to merge 3 new platforms in the next release after 6.18 already. That will be one of the IoT platforms, the QCS 8300 Carnapoli, that's one of the mobile platforms that was announced a few days ago. And Glimmer, that's one of the laptop platforms. And hopefully more platforms to come. And we are going to get 4x pipe, quad pipe. That should enable us to get 8K resolution support. That was also a job done by Lenaro, and thanks Junni. DisplayPort, it will undergo another huge rework. So today we discussed that with colleagues here, and I said that it is broken. The HPD on the DisplayPort sometimes works, sometimes does not. Usually it works on the laptops. I know a few corner cases when it does not, so you can plug the display and end up with the device saying that, yeah, DisplayPort is not available. We plan to fix that, and one of my colleagues from Qualcomm has been posting the MST support. So we are going to be one of the first embedded devices which has multi-stream support. On the DSI, we continue with the DSC fixes to enable more panels. And on HDMI, I plan to rework and finally merge work done by Arnaud from Free.fr, the CSC support. Longer term plans, well, we are going to work on secure context for the secure use cases. There was an RFC posted by a video team to enable or to extend DT support for the IMMUs. And we need that to enable secure playback and several other security related features. The next point is to plan to update the concurrent write back to earlier platforms to support cloning from the display to the write back for earlier generations. Continue migrating. One of the missing features for the DisplayPort is the DSC. There was a patch posted 2 years ago. It did not go in because it did not go up to the required quality, but hopefully that will be sorted. And one of the longer-term issues and one of the longer-term plans is to migrate DSI files also to a proper place to drivers PHY.
All right, on the GPU side, there's a few things we're looking at. So we'll need to add some new UAPI for performance counters, which I'll talk about a little bit more on the next slide. So DVCS is not ideal. Currently we're using Simple on Demand, and it lives up to its name. Probably we want something that's a little bit more eager to ramp up at lower OPPs when the cost is lower, and a little more conservative at higher OPPs. But that's still TBD. But you know, the current Simple on Demand doesn't make the right power versus performance interactivity trade-offs. Another feature we're starting to think about and look at is GMU hardware sketch. So we can pull not all, but some of the fences out and wait for them on the GPU or on the GMU firmware and remove some of the CPU latency from scheduling. Another big thing that's on our roadmap is protected surface. So, I mean, people here like protected content. It's actually really not just about that. For example, Android supports protected surfaces for apps, like if you're a banking app, for example, maybe you don't want anything else to be able to see the contents of that window. So you can imagine having a Wayland app that has a protected surface that gets pushed to the compositor. The compositor, you can't even read it, but can sample from it and render it to a protected scan-out buffer that the display can scan out. So, and as Dmitry mentioned, that in turn involves solving some issues about how we deal with multiple SMMU context banks, which currently is something missing in DTS device tree. Pardon? Oh, and then finally, there's LPAC, a separate asynchronous compute ring, and a never-ending stream of new hardware that's always coming out. You might have noticed the other day that GPU kernel support for Adreno 8X was posted. So really quickly, on the topic of performance counters, there's kind of two modes, local and global collection. So global counter collection is a cross process where you have like a central daemon like the Mesa PPS producer. The problem with this is it doesn't play nicely with IFPC. We have to disable IFPC when it's active, because if the GPU is power collapsed and we try and read counters, things go boom. So I'm thinking of new ioctl pass full counter configuration down to the kernel, return a file descriptor user space can read on. The kernel can handle the handshaking with the GMU to take care of the power situations. And then there's a separate, slightly related thing, which is local counter collection, an app collecting counters within its own command buffer. There's a problem if an app tries to use the same counters that a global counter collection is using. They'll kind of stomp on each other's feet. So it's kind of TBD how to solve that. I mean, multiple different apps collecting counters within their own command stream can use the same counters and not conflict with each other, but using one counter for global and local at the same time is mutually exclusive. And thank you. Questions?
Thanks a lot, Dmitry and Rob. Fortunately, we're a bit over time, so maybe we can have one question while we set up for the next remote speaker. Can we keep the mics on while I prepare the rest? Okay.
Maybe? Yes. Well, yeah, just wanted to say, Dmitry, thanks so much for all the work you've done in the common bridge connector HDMI helper code and for reviewing everyone else's drivers and stuff. You've made everything so much better, and thanks a lot for that. My actual question is, you've got like 6 different schemes of SoC names as well as model names that you've put up there. Can you please publish somewhere a mapping of like what all of those are, because I'm so sick of grepping Arch ARM64 boot DTS. Thank you.
Yeah, that trend most likely goes not to me, but to Bjorn and Konrad, and not even to them, but to the our marketing department. I can say that only one thing. I feel your pain. Because when I have to look what is Snapdragon 8 Gen something, I have to go to Wikipedia and check what's written there. Things might improve, but I can talk about that later. But yeah, thank you. Any more questions? Well, hopefully another quick question.